Okay, if you would please, let's find your textbooks and we're going to turn to page 132. We're going to take a look at some fishies. All right, the fish system of measurements. So you're thinking of purchasing an aquarium. You contact the owner of an aquarium store and you need to know how many fish to purchase for an aquarium. But first, you must determine how big the aquarium will be. The owner of the aquarium store tells you his rule of thumb is to purchase a total length of fish. Is to purchase a total length of fish of 3 inches for every 2 gallons of water in the aquarium. Okay, so 3 inches to 2 gallons. Okay, how many gallons of water would you need if you had a 4-inch fish and a 2-inch fish? Draw a diagram to explain. Well, I know that for every 3 inches, I need 2 gallons. Okay, that's my rule of thumb here. All right, so I'm told I have 1 4-inch fish and then 1 2-inch fish. All right. So let's take a look here. Let's see. 6 inches. So how many total inches do I have? I have a total of 6 inches worth of fish, okay, between the two. So I'm going to set up a proportion here of 3 inches over 2 gallons. I know that I have 6 inches, and I want to know how many gallons is this? Well, 3 to 2 or 3 to 6 is times 2. What I do on top, I must do on bottom. Well, 2 times 2 is 4 gallons total. 4 gallons. So define variables for the quantities that are changing in my problem. All right, so we're going to let F equal the inches for fish. Okay, we're going to let F equal the inches for the fish. And we're going to let W equal the gallons. Here you go, I'll write it out. W equal the gallons. Okay. So write an equation for each. So we're only going to write equation for the one. So fish inches based on the number of gallons of water. Okay. Well, I have my W. This is what I have. And I'm trying to find F. All right. So I am trying to find my F. And I'm going to use my ratio that I wrote up here. So I'm going to have F is equal to 3 over 2 W. So I'm looking for F and I have W. Okay. All right. Let's take a look at 3.1. All right, so let's graph each equation. So we're only going to graph the one equation that we did from our previous activity. So create a table of ordered pairs, then plot the ordered pairs to create a graph. So we are going to, let's see, mark out gallons. Yep, so we're going to mark out this one right here. We don't need this one, okay? Because our equation is F is equal to 3 over 2 W. F is equal to 3 over 2W. All right, so I want to know for fish inches, well, 0, let's do 0. Let's do 5, 10, 15. Let's just use the numbers that we have here. Oops, I need to flip those numbers. I don't know why I did that. Hang on. Because gallons is on bottom, so 0, 5, 10, and 15. All right, so let's take a look at this. If I have 0 gallons of water, am I going to have any fishes that can fit in there? No. Well, that's going to be 0, so I can plot a dot at 0. If I have 5 gallons of water, how many fishies am I going to have? Well, I'm going to plug 5 into my equation of 3 over 2 times 5. Okay, to equal 3 over 2 times 5 over 1, which is 15 over 2. So 15 divided by 2 is 7.5. Okay, I'm going to plug in 10 into my equation, so 3 over 2, and I'm going to go ahead and put this into a fraction to get 30 over 2, which is 15. Okay, and then I might not be able to get 15, but we can go ahead and try. So 3 over 2 times 15 over 1. Well, 3 times 15 is 45. And 45 divided by 2 is 22.5. Well, 5 is going to be at about 7.5, so 6, 7.5. And 10 is going to be right here up at 15. So find a straight edge wherever. And then we're going to draw our beautiful line here. There we go. Make it a little bit darker so y'all can see. And there's my equation. All right. So what does the point 0, 0 mean on my graph? Well, it means this: 0 gallons of water, 0 fish inches. ES. Okay. All right, so we're going to look at 3A right here because we only did one of the graphs. What does the point 6,9 on the fish inches per gallon represent in our problem? Well, 6,9 represents this. For 6 gallons of water, I can have 9 inches of fish. That's what it represents because X is the gallons and Y is the fish inches. Fish inches. It's a tongue twister. All right. And then let's take a look at C, because remember, we can only do one of these because we only did one graph. What does the 0.1 and 1.5 represent? Well, remember, X is the gallons, so 1 gallon can represent 1.5 inches of fish. So 1 gallon of water can represent 1.5 inches of fish. All right. Number 4, what is the unit rate for each graph? Well, let's go ahead and just do the unit rate for our graph and explain how we came up with that. So I want to know, what is my K value? Okay, what is my K value? All right, so my K value for this is 3 over 2. That's what my K value was. It was 3 inches for 2 gallons. All right, use your graph. We're only going to do letter A because remember, only one graph. So use your graph that we use to determine the answer. So how many fish inches can fit into 10 gallons of water? So we're going to have F is going to equal to 3 over 2, 10. All right, and we actually already did this, so let's go ahead and do this again. 3 over 2 times 10 over 1. Well, 3 times 10 is 30. Over 2 times 1 is 2. 30 divided by 2 is 15 gallons. Or no, 15 inches. Not gallons, inches of fish. It's a tongue twister. Inches of fish. Fish inches. Fishy inches. All right, number 6. Use one of the graphs to estimate each answer. So we're only going to use our graph, remember. Explain how you use the graph to determine the answer. So how many gallons would be needed for 16 inches of fish? All right, so let's take a look back here. So if I'm looking at 16, I know that 15 is going to be 10. So if I'm at 16, I might be at 11. Okay, so let's estimate. So let's sit here and see. I mean, about 16 would be right here. So we're going to come over and we're going to get really close, and we're going to see that if we come all the way down, we can estimate it to be about 11 gallons. Okay, so when we're estimating, we do not have to be absolutely accurate. All it wants to know is just a really good estimation. Okay, really good estimation. All right. Let's get away from some fishies and let's take a look at 3.2. All right, the graph shown displays the relationship of time and distance. Okay, time and distance here. All right, so define your variables and write an equation to represent the relationship Ella's distance and time. Well, let's remember distance and time. I want to use this equation here, d equals RT. All right, so I want to define my variables, okay? So I'm going to say t is equal to time and d is equal to distance. Okay, t is equal to time and d is going to equal to distance. And then what does it say? And then write an equation to represent Ella's distance and time. Well, I need to find my k value, or r, okay, because remember, k is equal to r, all right, in our problem, and to find it, it's going to be y over x. Well, let's see. Let's use this point right here. So I have 2 over 12. And 2 over 12 reduced is 1 over 6. So that's my r. So I'm going to plug in 1 over 6 for my r. So I'm going to have d is equal to 1 over 6t. All right, use your equation to answer the following question. How far can Ella run in 15 minutes? Well, I'm going to have d is equal to 1 over 6t. I know the number of minutes, so d is equal to 1 over 6 times 15. I can make 15 into a fraction, so 1 over 6 times 15 over 1 to get 15 over 6. And then I'm going to use my calculator to get that she can go 2.5 kilometers and then 15 minutes. All right. Letter B, how long does it take Ella to run 7.5 kilometers? Well, let's rewrite our equation. D equals RT. We know what R is. D is equal to 1 over 6t. Okay. I know my distance now. So that's 7.5 kilometers is equal to 1 over 6t. Now, I just want you to tell me how we would solve this. So right now, I'm multiplying 1 over 6. So the opposite of that is going to divide by 1 over 6. And what I do to one side, I have to do to the other. And I'm going to go ahead and tell you that 7.5 divided by 1 over 6 is 45 minutes. 45 minutes. All right, how far can Ella run in 1 hour? So D equals RT, D equals 1 over 6t. Well, we've been dealing with minutes. Well, how many minutes are in an hour? There are 60 minutes in 1 hour. So D is equal to 1 over 6. And I'm going to go ahead and write this as a fraction of 60 over 1 to get me 60 over 6, which is 10 kilometers. So she can go 10 kilometers in 1 hour. All right. Determine the constant of proportionality in kilometers per hour. Then write another equation that represents how Ella's distance d varies directly with time. Well, we already did that. Okay, we did that already. Let's not do that one again because we've already made that. All right. How is this equation similar to and different from the previous equation you wrote? Don't worry about it because we didn't write it. We don't need to deal with it. So mark out D and E, please. All right. So 3.3, determine the proportional relationships of our graph. So you've seen proportional relationships can be represented on graphs, and the constant of proportionality can be identified from the graph. Number 1, determine if each graph shows a proportional relationship between x and y. If possible, determine the constant of proportionality and explain how you determine the answer. Now, remember, here are my rules. Okay, first rule, straight line. Okay, second rule, it has to go through 0, 0. And third rule, COP, constant rate of proportionality. All right, well, let's take a look. Does letter A, does it pass my first rule? Yep, it passes my first rule. Does it pass my second? Does it go through 0, 0? No, it does not go through 0, 0. So then we're good. All right, letter B, does it pass my first test? Is it a straight line? Nope, it does not pass my first test of a straight line. All right, let's look at letter C. Does letter C pass my first one? Yep. Does it go through 0, 0? Yep. All right, let's see if we can find a constant of proportionality here. Let's see, it goes up by 4, so 1, 2, 3, 4, 5, 6, 7, 8. Let's see, can I find a nice one? Oh, look right here, I can. Let's use this coordinate point right here because I see that I'm at 2.0 for x, and then for y, I am at 6. All right, so remember, k is equal to y over x. So k is going to equal 6 over 2, which is 3. My constant of proportionality is 3. All right. Letter D, does it pass my first test of a straight line? Yep. Does it pass my second of going through 0, 0? Yep. So it's proportional. Now let's take a look. Let's find our k value. So remember, k is y over x, and we're going to have 10 over 50. Which is going to equal down to 1 over 5. 1 over 5. If you have any questions on any of that, please let us know.